Hi, everybody. In lesson one here in our statistics units, we're going to talk about describing distributions. So some of this is going to be new, some of this is going to be old, but in this lesson, we're going to explore how technology is going to help us do a lot of the statistical work that we're going to do in this unit. So students from River City High School were randomly selected and asked, how many pets do you currently own? So this is a statistical question, right? It's something that we want to answer. How many pets do you currently own? That varies between people, and we want to figure out kind of overall what is the typical number of pets that someone owns. So I took a sample and I have this many pets here: 0 pets, 1 pet, 3 pets, 2 pets, 2 pets, 0, 0, 1, 4, and so on. So if I asked you what's the typical number from this list, well, first of all, it's not even in order, which is annoying. But I can't really pick out what's the typical number of pets from this list. I see 10, 9, 8, 0, 1. Like the numbers are all over the place. So what we're going to do is we're going to visualize this data, and we're going to visualize it with dot plots or histograms, and we're going to use technology to make these. So pay attention right now because I'm going to teach you how to use Desmos right now to work with this data, and we're going to need to do this going forward this week and next week. So the first thing we're going to have to do is put this data into a list. So on Desmos, let me just take a picture of this data so I don't need to flip back and forth here. There we go. So on Desmos here, I'm going to make a list. And the way that we make a list is we need to give it a name. So let's call it L. I'm going to call it capital L for list. And I'm going to say L equals, well, what do I want the list to equal? I'm going to use these square brackets here. You could also get them from your keyboard, but we need a square bracket. And now I'm just going to type in all these numbers: 0, comma, 1, comma, they don't have to be in order. I'm just typing them all in, comma, 2, comma, 2, comma, 0, comma, 0. And this takes time. I know this is frustrating and this takes time, but that's how it works. 1, 10, comma, 1, comma, 1, comma, 2, comma, 1, comma, 1, comma, 9, 2 zeros, 2 zeros, a 7, oop, I forgot the comma, comma 7, comma 8, comma 4, comma 5, comma 3, comma 2, comma 3. All right, so I have my list of data here. L equals the list of all that numbers. And if I want to make a dot plot, I can literally type in dot plot. But if you go to functions here, we're in our statistics unit. So actually, I want distribution, sorry. So statistics, so functions, distributions, you can make a dot plot or a histogram. A dot plot of L. So I did the dot plot. You could literally type in the word dot plot if you don't want to go there. Dot plot L. And then see how there's this little plus button here? That's going to zoom into the dot plot for you. So there's the dot plot. Each dot represents one piece of data. And notice that they're stacked vertically on top of each other. So let me get rid of these grid lines. I don't need them. I have 1, 2, 3, 4, 5, 6 people that have two y-axis. I want it to go by ones. There we go. I have 1, 2, 3, 4, 5, 6 people who have 1 pet. So this lets me visualize my data and say, okay, most of my data is in this 0 to 3 range, and then I've got some crazy people over here with tons of pets. So that's a dot plot, but we could also make a histogram. So functions, distributions, I want to make a histogram. Well, a histogram of what? A histogram of capital L. So notice it's basically the same thing as the dot plot, but I can also group the data together. So maybe I want the bin width, a bin is the rectangle here. Maybe I want the bin width to be too long. So that way it does groups of 2 instead of groups of 1. But I'm going to just leave it as 1 right now. On the homework, I'm going to have you center it to the left, just so you know to do that. I kind of like it centered on the left rather than it being centered. So I can align the bins to the left. So on the homework, I'm going to have you change it to the left. And that's a histogram. I hit the plus sign to make it view it, hit the little plus sign there to make it nice and pretty, but there's my histogram. It kind of gives you a better overall idea of the shape. So how do I make a list in Desmos? I go there and I have to give it a name. You can call it whatever. A equals. What does A equal? Square brackets, and then you type in all the numbers. That's going to be important for the rest of the lessons in this week. So we did that. We can visualize it with a dot plot or histogram. We did that on Desmos. We did this on Desmos. We made a list. I said L equals square brackets, and I put all those numbers in it. And then I could do dot plot parentheses L or histogram parentheses L. So whatever you call the list, that's what goes in the set of parentheses. So the way that I describe the typical number is by the mean or the median. So hopefully you remember when I say the word mean, that means the average. How do I find the average? I add them up and divide by the how many. Divide by how many, right? I add up all the pieces of data and divide by how many. But we're not going to do that. We're going to let the technology do that for us. So I'm going to go back here, and this is when I'm going to go to statistics, function statistics. I want to find the mean, the average. Or what's nice about Desmos is you could literally type mean. The mean of what? The mean of that list. And the mean of that list is, there it is right there, 2.8. So the average is 2.8 pets. On average, people have 2.8 pets. The median, we're going to do the same thing. I could go to stats, median, or I could literally type in the word median of L. So the median of that list is 2. Well, what's the median? How are these two measures of center? These are measures of center. They're describing the middle of the distribution. This is the average. The median is the middle 50%. It splits the data in half. It splits the data so the median's in the middle. I have 50% on this side and 50% on that side. The median is in the middle. So the median number is 2. So in working with dot plots and histograms, we like to describe the shape of a distribution. And there's a couple shapes of these distributions I want to talk about here. So this first one is symmetric. It's symmetric because if I kind of draw a curve over this, it's like perfect on both sides. It's perfect on both sides there. Our distribution here was not symmetric. There's not that nice even symmetry or those two tails. These are called the tails of the distribution. And see how these kind of tails are the same. This guy's boring here. He's flat. He's kind of flat across the top. This is a uniform distribution. Just like when kids enroll in Catholic school, they have to wear uniforms. They all look the same. All the bars are the same. We don't have that either. This is not a uniform distribution. Everyone's not at the same height there. So what we have is we have a skewed distribution. These two distributions left here are skewed. So if I look at the tails here, which tail is longer here? Which way is the skew going towards? This guy is skewed to the right. Why? Because the data trails off to the right-hand side. That right-hand tail is longer. Whereas over here, which tail is longer? Where's the data trailing off to? This one is skewed to the left. This one is skewed to the left. So you follow the tail of the data. You follow this trailing off, the skew of the distribution. That tells you whether it's to the right or to the left. So symmetric, it's kind of perfect on both sides. And we can add the word approximately if it's not perfect, but we can be approximately symmetric. Or we're going to be dealing with skewed sets of data. So the shape of the distribution is going to be important to kind of describe, does it have that tail? Are there kind of outliers in the end there? Or is it perfectly symmetric? So in this case here, what shape were we working with? Our pet numbers, the number of pets we have, is clearly skewed to the right. The right-hand tail is longer. And finally, the last thing we're going to describe is the variability in the data. So statistics is all about variability, all about the randomness or the spread. How far spread out is my data? Is there a lot of variability or is there just a little variability? So I have two distributions here. Notice they're kind of both centered above 5. They're both kind of centered at 6 here, right? The center is 6, right? The mean and the median for both of these distributions is 6. But which one has more spread? Which one is the data more variable from the mean? So if we think about it, who's closer to the mean or who's more far spread out from the mean? So the black distribution, this one has more variability. This one has more variability here. Why? Because it's spread out from the center. It's more spread out, it's more spread from the center. Whereas the green distribution here has less variability. It has less variability. It's closer to the center. The data points are closer to the center, the average of the distribution. Most of the data is here, whereas over here, if I kind of do that middle circle, the data is more spread out. And the way that we measure this is with this number that we don't really need to get into, called the standard deviation. And the standard deviation is a measure of spread. It tells us how far am I from the average. What's the typical distance? What is the typical distance from the mean? So the standard deviation says how close am I, how far spread out is my data from the center? And on Desmos, it can find the standard deviation for us. So the way we're going to do that is we're going to go to statistics. Function, statistics, I want my STDEV, standard deviation. Well, what do I want the standard deviation of? Of list L. The standard deviation, here I have it called L1. Oh, sorry. Here I have the green one called L1. So the standard deviation of that green distribution is 1.47. It's going to be some crazy decimal. So S, we use the letter S for standard deviation, is 1.47. And I can also find the standard deviation of the black distribution here. So I'm going to do it again. Functions, standard dev, L2. This has a standard deviation of 2.75. Notice that the black distribution standard deviation is bigger. So the standard deviation is a measure of spread. The bigger the standard deviation, the more spread out your data is from the center. So notice that we could tell just by looking at it, this one has more spread compared to the green distribution. So the way that we measure that is the standard deviation. So we'll do a practice problem, then I'll see you in the next video. So 25 car owners were asked the age of their cars. The results are recorded below. Create a dot plot to represent this data. So let's go to Desmos and create a dot plot here. So I'm going to clear out everything I already did. Clear, 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 clear. So I'm going to call it, I'll call it lowercase a. A equals, so I'm going to make a list of data here. Well, how do I make a list? I use these square brackets. A equals, and now I have to type in all those numbers. But I already took a picture of this on my phone, so I'm ready to go. Here we go. Here comes the fun part. 0, 1, 2, 2. 3, 4. I can make a song out of this. 5, 6. I know it's tedious. Stop complaining. You're just typing in numbers. We could be doing all this by hand. 1, 2, 3, 4, 5, 6, 7. Oh, I think that was too many sevens. 1, 2, 3, 4, 5, 6. I only want 6 sevens. Goodbye. 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 I'm sure you missed that. And then I have 7 8s. 1, 2, 3, 4, 5, 6, 7. And notice it says I have 25 elements in this list, which makes sense because they said they asked 25 people. So create a dot plot. So watch this. I'm just going to type in dot plot. Dot plot parentheses. What am I making the dot plot of? Of A. And then I hit the little plus sign here to make it zoom in nicely. There we go. So on your homework, I'm going to have you copy and paste this. And the way that you're going to do that is you're going to hit this little button up here, share graph, export image. And then look right here. We can just copy and paste this. You can download it and input it, or you can just say copy, paste. So look right here. I just pasted. Let me move to the side a little bit more. There we go. I just pasted that graph. Let me drag him over. There we go. So you can hit copy paste. So how do I share this again? So on your homework later, I'm going to have you share it. So share this little button up here, export image, copy paste, or you can download the file and input it like you do normally. So describe the shape of this distribution. So here's my dot plot. What's the shape of this distribution? Well, which tail is longer? Where does the data skew off to? It skews to the left. It is skewed to the left. It has a left skew. Compute the mean and the median. So sometimes when I talk about the mean, I use the symbol X bar. That symbol X bar represents the average, the mean. So I'm going to go back to Desmos now and just say, give me the mean and the median. Functions mean of A. I want the median as well. So you could type in the word median or function statistics median of A. So the mean is 5.84 and the median is 7. 5.84 and the median is 7. Notice the mean is smaller because the mean gets pulled by the skew. The mean gets pulled by the skew. Or if we had an outlier, if someone let's say had 100 pets, the mean gets pulled in the direction of an outlier, right? If someone was over here with 15 or even 20 pets, that would be an outlier because that's a really unusual value. I know you've heard that word before in 6th grade and in 7th grade, outliers. Those are data values that are really extreme. Compute the standard deviation for this sample. So the standard deviation, that comes right from our calculator here. So functions STDEV, standard deviation of A, is 2.46. 2.46. It's a measure of spread. On average, I'm 2.46 from the center, from the mean. And finally, the last thing that I saved for the end was the range. When I talk about the range, I'm talking about the maximum minus the minimum. How far apart are they? The highest minus the lowest. Well, this one we can figure out pretty easily. What's my high? How high do I go? Well, it's 8, or I could use my data here, functions max. The maximum of A is 8. So if you couldn't tell just by looking at it, or if the data wasn't in order, you could use your Desmos here. Max of A, min of A, 8 minus 0. So 8 minus 0, the range is 8. The range is another measure of spread. How far away is the highest and the lowest piece of data? So rewatch this video if you need to focus on how to use Desmos, but I need you getting used to using Desmos to do some statistical work because we're going to use it again in the next lesson and next week. I'll see you guys in the next video.